S12 dibromobutane. So it's a butane, right? 4-carbon chain. And then 1,2 dibromo. So we got the 2 bromines. One is the carbon number 1, the other is carbon number 2. Only one of the S is given, but this S configuration is given to the carbon number 1 or 2. It didn't say anything about the number here. So it's up to you to figure out which carbon this cell's cell and the configuration applies to. Is it going to apply to carbon number 1 or 2? Which means you need to figure out which one is the cell carbon. Which one has 4 different substituents, right? This one, you got the 2 hydrogen there. Anytime you got 2 of the same thing, it won't be a steric center. So carbon number 1 is not a steric center. S doesn't apply to carbon number 1. S applies to carbon number 2, because that's the one with the 4 different substituents. The drawing I did does not really show that it has configured. So I have to draw it with an S. So as I said, it could be this, or it could be from in the back. I don't know which way it has to be. So what I normally do, I draw this way, and then I check if it's an S or R. If it's an S, my guess is right. If it's the other one, I just have to change the positions. So let's find out if this is an S or R. Bromine gets the first priority, and that's number 1. And there's which was number 2 between those 2 carbons. This carbon has a bromine and 2 hydrogen. That carbon is a 1 carbon and 2 hydrogens. So you can easily see that this is a number 2, that's number 3. Okay. So, and the fourth one in the back, this is the reason why I put the bromine at the top. I'm making arbitrary gas, so I can make the guessing easily of both sides instead of chemistry. So that's why I did that way. And 1, 2, 3, you connect it, and the fourth one in the back, it goes counterclockwise. So that means my guess is right. So I'm lucky. I'm going to have to change it. I will have to simply move on. That's the what we want to draw the Fischer projections. So this is the first step. You have to draw it in the regular, diagonal drawing. Now you convert it to a Fischer projection with a 1 steric center. It's pretty simple. 1 steric center. Yeah, so simply just 1 cross, right? 1 vertical line, 1 horizontal line. That's a carbon number 2, this one. Which one are we going to put on the top? Well, we don't see any oxygen there. It really doesn't matter anyway. But anytime you get the other types of heteroatom substituted, we would consider as oxidized. Bromine substituted, nitrogen substituted, sulfur substituted. Those are the way to get things oxidized. So I will put this one on top and then regular hydrocarbon on the bottom. But in case you do it the other way, it's totally fine. You just have a Fischer projection drawn 180 degree rotated, which is the same. So this H2 bromine on top, that thing at the bottom. Now we know how we're going to look at this molecule, right? We need to make these 2 carbon bond goes away from you. So you cannot lie down and looking up, right? You have to look at the molecule from the ceiling, looking down. We just put this H2Br on the top side. So your head has to be this way, your feet has to be the other way. It's all because we put that one on top. If you put this one on the bottom, then you just have to switch. Now, you're looking down, bromine is coming out of the screen, right? Which is on my left-hand side. So bromine goes left, hydrogen goes right. Again, this is what I got. After that, I'll double check. We already know that's S configured, so this got to be S. So let's do that. Bromine gets number 1 priority. This gets number 2. That gets number 3. That goes clockwise. So which one wrong, right? That's the thing people can easily forget. Hydrogen in the horizontal line, that means hydrogens are coming toward you. You're looking at the molecule in the wrong directions. So that's something you really have to make sure. So 1, 2, 3 looks like you're going clockwise because you're looking at the opposite side. So when you look for the right side, arrow will change in the other directions. So that's S configured. So I will double check. How can you do it? Even I do that. I think you should do it. You can easily prevent the making mistake by assigning absolute configuration. I know it takes time, but that's how much you have to get used to it. All right, that's basically what I just talked about. 3 minutes. I think we can do this one. Okay. Now we got the two steric 2s, 4s, 2 bromo, 4 methyl hexane. Now the 6 carbon. Is this the one? I don't know. I just arbitrarily guessed again. This is the bromine here, 2 position, 4 position methyl groups, 2 steric. That's something I can know. And something we know. But I don't know whether the bromine has to be this way, the methyl has to be that way. It's something that I will just guess. And then I will check whether that's the right guess by assigning absolute configuration. So let's find out what this S to R. Bromine gets number 1. This whole thing gets number 2. Methyl gets number 3. Hydrogen number 4. 1, 2, 3. That goes clockwise. So that means I guessed wrong for that part. So I will basically swap these two, and that will make it S later. Now check this one. I got this one, carbon, carbon, carbon. So you have to find out what each carbon can substitute. That with the 3 hydrogen, this one with the 1 carbon, with the 2 hydrogen, 1 carbon, and then 2 hydrogen. It's the same for up to this part. So we got to go further. Now look at this one. That one gets bromine, hydrogen, carbon. This one gets just 3 hydrogen. So that means that this whole thing gets the number 1 priority. That means number 2. That's number 3. 1, 2, 3. That goes counterclockwise. So at least I guessed that one right. So that's S. So that's S. These ones are R. But I was supposed to draw S and S. So what I do, I just swap these two together. That makes it S. This was S. Now we have to draw the Fischer projection of that. 2 steric center again, but you have to draw the 3 lines. All because you cannot draw just 2. That means that this one is in the structure. You have to draw 3 lines. Which one goes top? Which one goes bottom? Well, these are all methyl groups here, so I guess I'll just use a methyl goes top because it's closer to the center. I mean, substitution point, and then go down. If I just set that way, then now you know how to look at the molecule. Should I look at the molecule from the ceiling or I feel like to find out the center of this one? Yeah, because the 2 vertical line has to go away from you, so you have to look from the ceiling, looking down. Bromine is behind the screen, right? That means it's on my right hand side. And then this becomes a CH2, just 2 hydrogen. And then the methyls coming out of the screen, that coming toward you, that is on your left hand side. So I put left hand side there. So this should be the Fischer projection of this molecule. But once you draw the things that we should do before turning in your paper, checking the steric center, making sure that you get the right configuration.